What's up, Audiophiles? I'm here with Gary at Audiophile Zone. I'm here with Alberto from AGD Designs, come to speak about his fantastic Class D amps. What's up, Alberto?
Hey, Gary, how you doing? Thank you for inviting me.
All right.
Well, I mean, what's up? I mean, I don't know. We are trying to do something different than most of the companies and products that are available in the market. So,
Right.
Try to do our best.
First of all, let's talk a little bit about your background. You got a fascinating background. Why don't you tell us a little bit about how you got started in this field?
Well, that's very good. It's an interesting question. I don't know how much time we have, but ultimately it's very simple. I mean, audio has been always my passion since ever. But my career has been in, of course, in a different field at the beginning, at least for the past first 40 years of my life, was actually in power semiconductor, power electronics, where I've been working with many companies. And actually, most importantly, I moved in the United States, and specifically in California in '97. I've been here since 1997. So that's pretty much the story. I happen to work with great people and great companies. I learn a lot, and I hope I also contribute a little bit. And specifically in the last few years of my life in the semiconductor business, I've been very highly involved with the gallium nitride power semiconductors. And because of that, and because the passion I always had, I put together these two interesting, elements, and I decided to start AGD as an innovative and new company in the audio business.
Right. Did you develop the gallium nitride devices when you were at International Rectifier?
Yes, I was part of the team that actually made so great innovation in this field. And specifically, that gallium nitride MOSFET that we have developed is the core, the essence of most of my amplifiers today. Yes.
Yeah, we're going to be talking about that a little bit later. But let's, first thing a lot of people ask me about is they ask me, what is a Class D amp? So we're going to go briefly over the different amplifier classes. And, a lot of people have a very weak understanding about what this means. So We'll go ahead to the next slide. And this is a Class A amplifier. How would you characterize this?
Well, again, so it's interesting because this is a question that every time everybody asks, and helps me actually to remove some misconception relative to the Class D actually. So Class A, Class AB, Class C, D, and so forth are just a classification of circuit topology that was done by engineers. Instead of using names or numbers, they decided to assign a letter to the specific topology of an amplifier. The first one was Class A, and fundamentally a single device or eventually also two devices can actually amplify without any discontinuity of operation of each device or single device, the signal that is input into the device.
Right. That's an interesting point you bring up, because people think A, B, C is like a grade.
No, not at all. Not at all. I mean, engineers probably has a very little fantasy, and at least for nomenclature, I suppose they could have been calling class beautiful, class less beautiful, class very efficient, and so forth. But instead, they just simply named A, B, C, D, E, F, G, H. And that's actually the number of different topology of amplification that exist. So the Class A was just the very first that was created. And that was the name number one, then A. First letter of the alphabet, and then they continue with B, C, D, E. It has nothing to do with the grade or the quality per se.
That's right. Zero. Yeah. And the Class D amplifier basically what the device conducts through the full cycle of the signal.
And the Class A, yes, yeah, the Class A, yeah. So again, so the Class A, as I said, was the first example, and actually was the first circuitry that was implemented using a triode. The triode is the first electronic component that was conceived to amplify a signal, specifically for telephone communication. The biggest problem that was in existence at the start of the 1900s was how to transmit the signal, the voice, of the telephone at a longer distance, and eventually after that was the radio transmission that required, of course, amplification as well. But ultimately, that was the origin of all the amplifiers. So how to transmit at longer distance a signal for telephone communication, for telecommunication.
Right. Let's talk a little bit. There are a couple of very strange things I see. One thing I see is that a lot of people talk about single-ended tubes, and they're always saying it's Class A.
That is a single-ended transistor.
Of course, it's Class A because you can't work any other way.
Yeah.
That has nothing to do with the quality of the unit.
No.
And let's talk about some of the deficits of Class A. Well, number one, very inefficient.
Yes, that's exactly why Class A devices are either very low power, or if they have to really have a lot of power, you have to really design something that can dissipate a lot of heat, because ultimately that device that you see now is represented by a transistor, that could be a triode, have the unfortunate situation to let's say drive current with extremely low efficiency, because 50% of that or more is actually dissipated in heat. The device is constantly conducting, and therefore has the problem of having a huge amount of heat dissipated. And that was not a problem 100 years ago, and it started to get a problem today, and actually even before. So yeah, inefficiency is the problem of Class A. Electrical inefficiency, of course, energy inefficiency.
Right. So what they did was they developed the next class, the Class AB, to address some of these problems.
Yeah. So that was exactly a little bit of variation in which through a bias circuitry it's possible to maintain the conduction only for 50% of the time, if you wish, or half the cycle. That would be the most correct way of doing. The Class AB, of course, is a little bit more efficient. Definitely more efficient than Class A, but then has the problem that, of course, by operating the device in this way, you have to discover how to deal with the crossover, the intermodulation distortion, and all the other elements related to the fact that these two components may not exactly the same, performing with the same identical physical characteristics, and therefore the results may not be as perfect as they should be. But again, so the Class AB has been an incredibly efficient and a successful topology for many years. Right.
Now we come to your specialty of the Class D amplifier. This was an answer for the Class AB and Class A inefficiencies. They're a completely different design.
Well, yes, absolutely. And again, so it's not. Of course, I've been working on this topology specifically for my goal in terms of results. But per se, Class D is not a novelty. It was originally conceived as a concept in the 30s, was actually developed physically in the 50s, and we have the very first example of application in Class D in early 1960s, 63, 64. But the fundamental problem was that, and it's still today, is a work in progress in terms of improvement, the performance of the device, or the characteristic of the device. At the time, there were no electronic component that could actually be used in order to take the full advantage of this topology. D doesn't stand for digital at all. As I said before, D is just the fourth letter and the fourth topology that was conceived. But it is a switching amplifier. So basically, the output devices are not operated in a linear condition, if you wish, in a linear zone of the device, but they're rather operated in either full conduction or full interdiction. So when they're either completely on or completely off. And that is where a semiconductor device operates at the highest efficiency mode. Of course, when it's off, there is pretty much no current, and so there is no dissipation. And when it's fully on, then the MOSFETs have an extremely low RDS(on), and therefore the losses in terms of resistive losses are extremely low. And intrinsically, the Class D has two, incredible advantages. One could be extremely efficient, and the more efficient is the semiconductor used, the better it is. You can reach efficiency of 95% or even 98%. But from the other important element is that technically speaking, the most linear amplifier that you can devise, because it seems to be almost a paradox, because the device are not operating in any linear zone of the device itself, which per se is not a perfect zone. Is only a very limited amount of operation condition in which the device is almost linear, if you wish. But therefore, it is only related to the overall condition of the design and the filter and so forth. So it's intrinsically the most linear device, and actually, theoretically speaking, with the one with the lowest distortion, naturally speaking, that it could possibly have.
Right. Now, let's talk a little bit. Class D amplifiers came first before the gallium nitride devices actually started to dominate the Class D market.
Yeah, I mean, the Class D, as I said, as a concept, as a switching amplifier, was conceived in the 30s, when actually there was no semiconductor. Everything was a tube. It was a vacuum tube, so it was very slow. It was, in reality, then improved and finally patented in the 50s by the same people, the same engineer that actually did the PCM, first PCM patent, the pulse code modulation. And through that, he conceived that it was possible to apply the same principle into the amplification of signal. And by modulating duty cycle, could obtain, through then a filter, the reconstruction of the input amplified, right? The input signal eventually amplified. So yes, and so the Class D was originally conceived as a good way of improving efficiency, but the semiconductor available transistor, bipolar transistor in the 60s were not good enough. You have to fast forward at least 20 years to get in the middle of the 80s, when the invention and the introduction of the MOSFET, the silicon MOSFET, and specifically at the time the XFET made by International Rectifier, to really open the opportunity for Class D to be utilized in practical application. And in fact, one of the very first was made by, amplifier that could actually sound decently, were made by Sony in 1984. And more or less at the same time, I think very, very notable, Bob Carver designed a very intriguing switching amplifier as well. So the first example of design with Class D that actually entered in the environment, the space of high-end audio was actually, or audio if you wish, music reproduction, was already in the early 80s. Again, the fundamental limitation of those circuitry were basically related to the imperfection, if you wish, or the limitation of the semiconductor utilized. And also, I think very importantly, because there were not enough knowledge, all these design were probably made by people that had only experience in linear design and analog linear design. So it's actually a complete different set of knowledge and design rules that has to be applied to switching circuitry compared to linear circuitry. But of course, the efficiency is a tremendous opportunity for improvements. I like to make example about the difference between a linear power supply, that is, what has been used until, the 80s, and a switching power supply. So the same can be as a comparison made for amplifiers. So today we have wonderful and powerful electronics, tablets, phone, and incredible powerful computer. And you have 60 watt, maybe 100 watt power supply for your desktop or powerful notebook. If you only remember, and again, that is unfortunately related to the age of the listener, that's really an issue. The size of a power supply, a linear power supply for 60 watt or 100 watt would have been, huge compared to the size of the product. So imagine to go around with your notebook, but with a 10 kilograms or 15 kilograms power supply, linear power supply with a transformer. And that is the extent of the improvement that the switching technology and MOSFET eventually actually have done into the world of electronics and the technology. Without that, conversion from if you wish, linear power supply to switching power supply, we have today the product that we are using and we give us, for grant every single day. Different, of course, has been for audio because you don't have to charge a battery. You need to listen to, and so the improvement of the quality has been a little bit more challenging, fundamentally because the limitation of the components and the lack of knowledge, experience, or understanding how to optimize the circuit by the designers. Was a lack of experience. But
Right.
today, this experience exists, and the components actually are available. And that's
Right.
why I think it would be, that was basically my mission when I started this activity, to remove the stain of bad sound from the Class D, and
Right.
why that topology was not yet used in high-end audio. And my task was actually to demonstrate that can be done. And I hope I've done it, or at least I've begun to do it.
Right. It reminds me of the transition between tubes and transistors back long time ago.
Even before,
Yeah.
in the early 60s. Yeah, every
Right.
20 years or 30 years, electronics have fundamental, changes.
Right. They understood how to make the circuit work, but they didn't know how to make it sound good. They didn't understand the bipolar devices coming from a tube background. It's like a completely different device.
Right.
The voltage device versus the current device.
Yeah.
And the same thing in Class D. Class D was basically for, like you say, power supplies, things like that. In fact, the gallium nitride device is developed for power applications mostly, right?
Well, actually, yes. I mean, the gallium nitride has been until early 2000, 2010, only used in very high frequency application, and mostly, honestly, mostly for high rel military type of application, aviation, radar, or extremely expensive and unique type of application, because the manufacturing, the design, the construction, the physical creation of the product was extremely difficult, extremely challenging. Fortunately, that is not true anymore, and the gallium nitride has been already used in many let's say normal application, more consumer oriented, fortunately. And so with that, the cost went down. The opportunity to use the gallium nitride instead of silicon, and therefore implementing immediately the efficiency improvements and performance improvement that the new material is bringing to the party. And so is already available now. And but not very many actually. I think that AGD was the very first company that introduced a power amplifier with Class D, in Class D with using gallium nitride. Technics was just a few months later, I guess, and then after that, several other companies enter into this field.
Right. So that brings us to our next slide. We're going to be talking about what makes the AGD design different.
Well, I guess that one of the most evident characteristic why it makes different is that we really tried to do something almost unique. And so we encased the entire power stage of the Class D inside a glass tube. And there's been a lot of conversation about it, and I received so many questions why I did it. So I don't know if we have time to talk about that, but there is one element that is the design, this aesthetical design, the uniqueness of that, which is one part of the answer. And then of course there is the technical, more specific of the circuitry that is another part of it. So fundamentally, all of this design that I created and are available today are based on gallium nitride, and specifically, most of them are based on a design that I started, and I was part of the team that developed the semiconductor per se, so the physical device. So the uniqueness is that device is only available to AGD, simply because at the time when we created this device, and eventually the company went through different let's say hiccups, I bought the entire inventory of this specific product, and therefore there is not it's not possible for anybody else actually to get this specific device. And it is important because that device was optimized for application like Class D. It was not a device that was conceived or optimized for a battery charger or any other different application. And there's a very fundamental difference between operating a device like that in a battery charger and in a Class D. Fundamentally different. So thanks to the optimization that was done at the time, these are absolutely unique devices. Then if we have to talk about the glass, and the reason for that, well, that is actually as a two elements, one engineering, one element that is clearly engineering related, and one that is, of course, related to the marketing related. As I said at the beginning, my goal with AGD was really to help and remove the stain of bad sound from the Class D topology. And in order to do that, I had to have a perfect circuitry, or very, very close to perfection, to deliver that type of quality, but at the same time, a look that was not going to scare anybody by approaching a Class D amplifier that carrying this load of bad sound, it would have been challenging to promote if I had chosen to go with a different look. The tube is actually an element of deep element of engineering, challenges, thanks to the fact I can make the device so efficient and so doesn't require heat sinking. I can miniaturize everything and fit into the tube. Number two, and so if anybody has seen this tube, you will probably recognize that the size of the heatsink is totally minuscule. I mean, it's absolutely small. That is an element that enabled me to put that into that, for sure, the miniaturization and the efficiency. But number two, the fact that is ultimately based on an octal socket and it's easy to replace, I have basically designed a system that is going to last from the point of view of performance forever, because at the time when a new, more advanced device will be introduced in the market and I will have the chance to use it, well, this device can be mounted in the same way, and I can simply swap the tube, and you save, you're protected on the investment of the amplifier per se, because ultimately by changing the tube you have immediately an improvement in performance and overall results. So the module concept, which is physically now a tube, is also very important to maintain the value of the product of the amplifier in time. You preserve that investment for forever, basically. And then it's also very easy to upgrade and also very easy to repair eventually, right? So I don't think there are very many products in the audio business in which you can physically upgrade or replace the power stage in less than 5 seconds without a screwdriver. Anybody can do it. And even more importantly, and it's rule number one in marketing, you don't have to electrocute anybody to do that. And, preserving the customer base by not killing the customer is very important. So you can upgrade, everybody can do it, easy. There is no need of any screwdriver, and it's just plug and play. That was fundamentally the idea as well. So
right, it's interesting that a lot of people are coming out with Class D amplifiers, but a lot of them are based on modules that are made by certain companies, and a lot of them are made by they put out engineering kits and they just slap it together. They really have no understanding. I've seen some manufacturers that are basically analog manufacturers. They really don't understand the ins and outs of a Class D design, and they're putting out Class D. So this is the difference. You are a true expert in this field, in this particular Class D amplification and the application audio. That's what makes these amps different. And I will say it's the best sounding Class D amp I've heard.
Yes, thank you. I mean, your opinion is actually, thank you. I mean, there are a few customers of mine that share the same opinion that you have, and I'm very, very happy and very proud of that. And yes, going back to what you were saying about the other manufacturers basically are using modules made by somebody else and just put in a case. I cannot say they're amplifier manufacturers. Simply, they design a case and they put somebody else's product. So we have basically designed every single part of every product that we have created is designed internally, to the extent that I even went back to the fundamental product, so the gallium nitride, since I was part of that team years ago that developed that. So really, A to Z is owned by AGD in terms of knowledge. So to me, that is quite important, as I suppose I still believe has a certain value. And I will defend that value, and that is the style of the company, the mission of the company.
Okay, well, I will say we're gonna we're coming to the end of this interview, but if you want to hear these amps, we'll be showing them at Axpona, of course.
Yep.
And that's room 722.
Look, Gary, I don't remember. I don't remember.
On the website.
I think it's room 722. Yes, we've been in that room for the past 3 years, because we have been at Axpona only twice. Unfortunately, the COVID actually hit, and then as many others could not really attend the Axpona show, and I think we have been in 722. But
right. That's Axpona in Chicago. That's coming up on April 14th through 16th, correct?
A month from now, more or less.
Right. Yep. And then you're also going to be showing the amps at the show in Costa Mesa. That's June 11th through 13th.
Yes.
At Costa Mesa, California. So if you get a chance, you should come out and listen to these things. There's also a generous audition policy with AGD where you can actually hear these amps in your system.
Exactly. We have a 14 days of policy, return policy. So a lot of people have taken advantage of that. And very, very, very few has decided to return the product. Very, very few.
All right, Alberto, we'll be talking to you soon.
Thank you, Gary.
And we'll see you at Axpona.
See you at Axpona.